Hello everyone, welcome back to ANR Academy. Today we are going to discuss the conditions for equilateral triangle. If Z1, Z2, Z3 are vertices of equilateral triangle in organ plane, then the three conditions are here. One is Z1 square plus Z2 square plus Z3 square equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1, and the second one Z1 minus Z2 whole square plus Z2 minus Z3 whole square plus Z3 minus Z1 whole square is 0, and the third one sum of reciprocals of Z1 minus Z2, Z2 minus Z3 and Z3 minus Z1 also 0. And here these are the results we can prove with the help of Coney method, and you can easily remember first two results by 8th class result, 8th standard result. You know that if A plus B plus C is 0, then you know that A cube plus B cube plus C cube minus 3 times of ABC, which is 0. And also you can factorize this. One is A plus B plus C and the other A square plus B square plus C square minus AB minus BC minus CA, which is equal to 0. Also you can write A plus B plus C, which is multiplied by A minus B whole square plus B minus C whole square plus C minus A whole square equal to 0. And here if you observe the second factor, the results are of this form. First one, A square plus B square plus C square equal to AB plus BC plus CA model. And the second one, A minus B whole square plus B minus C whole square plus C minus A whole square equal to 0. So you can easily remember first two results. And the third one, sum of reciprocals of Z1 minus Z2, Z2 minus Z3, Z3 minus Z1 also 0. Let us see the proof of this. There is an equilateral triangle ABC, and in organ plane the vertices are denoted by complex numbers Z1, Z2, Z3. You know this. And all the three sides are equal in length and vertical angle must be 60 degrees. Suppose that AB is a vector denoted by Z2 minus Z1 vector, and AC is another vector, it is denoted by Z3 minus Z1 vector. Final point Z3, initial point Z1, so that it is denoted by Z3 minus Z1 vector. And here final point Z2, initial point Z1, so that it is denoted by Z2 minus Z1 vector. And from Coney method or by rotation theorem says that here final wala Z3 minus Z1 divided by initial wala Z2 minus Z1, which is equal to length of Z3 minus Z1 divided by length of Z2 minus Z1 multiplied by e power I theta, where theta is angle between initial and final vectors. That is, here the angle made by initial and final vectors 60 degrees, so that it is written as e power I theta. Yes, this is the result by Coney method. Now here in the right part, length of Z3 minus Z1, length of Z2 minus Z1, both are same, and hence these two terms gets cancelled. In the left side you can write Z3 minus Z1 divided by Z2 minus Z1, which is equal to, right hand side it is e power I theta. E power I theta is Euler form of complex number, that can be written as cos theta plus I sin theta, cos 60 degrees value 1 by 2, next plus I sin 60 degrees value root 3 divided by 2. Now simplify this. Z3 minus Z1 divided by Z2 minus Z1 minus half equal to I root 3 divided by 2. On simplifying this, we get 2 times Z3 minus 2 times Z1 minus Z2 plus Z1 whole divided by 2 times Z2 minus Z1, which is equal to I of root 3 by 2. 2 gets cancelled. And now on cross multiplication, here the numerator part after simplification 2 times of Z3 minus Z1 minus Z2, that is equal to I into root 3 of Z2 minus Z1. Now applying square on both the sides, what happens, observe. On expanding this, after applying square and expanding this, we get 4 times Z3 whole square plus Z1 whole square plus Z2 whole square, next minus 4 times of Z3 Z1 plus 2 times of Z1 Z2, next minus 4 times of Z2 Z3, which is equal to, here I square value minus 1, root 3 whole square value 3, so we get minus 3 of, next Z2 minus Z1 whole square value Z2 square plus Z1 square minus 2 times of Z1 Z2. If you simplify this, you will get 4 times of Z3 square and 4 times of Z2 square, 4 times of Z1 square, next minus 4 Z1 Z3 minus 4 Z1 Z2 minus 4 Z2 Z3. Neglecting 4, we get Z1 square plus Z2 square plus Z3 square minus Z1 Z2 minus Z2 Z3 minus Z3 Z1, which is equal to 0. So from this you can write Z1 square plus Z2 square plus Z3 square, the value become Z1 Z2 plus Z2 Z3 plus Z3 Z1. So this is first result. You have here the first result. Next, and you can easily get the second one just by multiplying with 2 on both the sides. Here you have first result, Z1 square plus Z2 square plus Z3 square, which is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Just multiply 2 on both the sides. Here 2 and here another 2. Now what happens? 2 times of Z1 square, that is Z1 square plus Z1 square. Next Z2 square plus Z2 square. Z3 square plus Z3 square. Minus 2 of Z1 Z2 minus 2 of Z2 Z3 minus 2 of Z3 Z1 is 0. Now Z1 square Z2 square and minus 2 Z1 Z2 written as Z1 minus Z2 whole square. Next Z2 square Z3 square and minus 2 Z2 Z3. The combination of these three become Z2 minus Z3 whole square, and the remaining terms can be written as Z3 minus Z1 whole square. In the right part you have 0. Yes, this is second result. Next, to prove sum of reciprocals of Z1 minus Z2, Z2 minus Z3, Z3 minus Z1 0, let us see, let us suppose that small a, which is Z1 minus Z2, and assume small b Z2 minus Z3, small c, that is Z3 minus Z1. I am going to assume the value of Z1 minus Z2a, Z2 minus Z3b, Z3 minus Z1c. What happens if you had all these a plus b plus c, that become 0 clearly. Plus Z1, negative Z1, positive Z2, negative Z2, positive Z3, negative Z3 gets cancelled, we get 0. And also you have the second result. What second result says? Z1 minus Z2 whole square. From the second result, Z1 minus Z2 whole square plus Z2 minus Z3 whole square, Z3 minus Z1 whole square, which is 0. That is a square plus b square plus c square is 0. With the help of these two results, I am going to use a plus b plus c 0, a square plus b square plus c square equal to 0. With the help of these two, now I am going to write a square plus b square plus c square 0 as, from this the value of c written as minus a minus b. And hence what happens after expansion, a square plus b square plus a square plus b square plus 2ab, which is 0. So that 2 times of a square plus b square plus ab, that become 0, and hence a square plus b square plus ab is 0. Now from this you can write the value of ab equal to minus a square minus b square, and similarly you can prove the value of bc as minus b square minus c square, and the value of ca as minus c square minus a square. Now adding all these, we get ab plus bc plus ca, which is equal to minus 2 times of a square plus b square plus c square. But a square plus b square plus c square you have here 0, and hence ab plus bc plus ca becomes 0. Dividing each and every term with abc. Yes, on division with abc, what happens, observe, AB gets cancelled 1 by C, BC gets cancelled 1 by A, AC gets cancelled 1 by B. So reciprocal of A, B, C, and whose combination become 0. You got the result 1 by A plus 1 by B plus 1 by C 0. What is the value of A? A is clearly Z1 minus Z2. Next 1 by B, that is Z2 minus Z3. Next 1 by C, that is Z3 minus Z1, that become 0. And hence the third result proved. Just what I am doing here, selecting A, B, C as Z1 minus Z2, Z2 minus Z3, Z3 minus Z1, A plus B plus C value becomes 0. And also by the second result, A square plus B square plus C square also 0. With the help of these two, we got one result, that is AB equal to minus A square B square. Similarly, we can prove BC value as well as CA value also. You will get in this way. Adding all the three, AB plus BC plus CA combination, that becomes 0. In the next step, dividing each and every term with ABC, you got 1 by A plus 1 by B plus 1 by C 0. That is sum of reciprocals of Z1 minus Z2, Z2 minus Z3, Z3 minus Z1, that become 0. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.